Hello guys, welcome to BYJU'S exam prep. Welcome to Coffee with Concepts. In this session, I am going to explain about the motor which may rotate in reverse direction at the time of starting. Okay. Before moving on to the session, let me explain about myself. My name is Naveen Gollapalli. I have around 11 plus years of experience in teaching. Most of the times I'll be teaching circuits, machines, measurements and power systems. I did my masters in power system from JNTU Hyderabad, cracked GATE and State Public Service Commission examinations, and I taught more than 20,000 students since 2012. This is a small introduction about myself. Moving on to the session. Once again, let me repeat. Here we are going to discuss about the motor may rotate in reverse direction at the time of starting. Okay. So if you are expecting the motor to rotate in reverse direction, first take a reference direction. I am taking a reference direction. The reference direction is clockwise. It is your wish, you can take up anti-clockwise. As I have shown the figure here, this is rotating, the motor is rotating in the clockwise direction. I have taken the reference direction as clockwise. Okay. Now, the moment when you switch on the motor, this must rotate in clockwise direction only. If any motor is designed to rotate in clockwise direction, every time you switch on the motor, it has to rotate in clockwise direction only. But there is one such motor which may rotate in reverse direction at the time of starting. Now let us discuss what is the reason behind the reverse direction at the time of starting. Before getting into or before finding out the reason for the reverse direction, let us have a brief discussion on clockwise direction. How do you get a clockwise direction? It is because of clockwise force. The force is a function of flux and the current carrying conductor. So the flux will be produced by this north pole and south pole, the stator poles, and there is a current carrying conductor on the rotor coils. The current carrying conductors will produce a flux and it is going to interact with the permanent magnetic fields due to stator poles, and therefore a force will be induced, and that force we are expecting in the clockwise direction. Now here, if you want to get the force in the reverse direction, now here to get anti-clockwise direction of force, either flux direction has to reverse or otherwise current direction has to be reversed. Then force will be anti-clockwise. Now how do you reverse the current direction? How do you reverse the flux direction? We will see. We are not going to change the direction of current. We are not going to change the direction of flux. In the machine, it is going to happen. There might be change in direction of current, there might be change in direction of flux. So due to any one of these, the force production on the rotor coils or rotor conductors will change, and hence the motor might try to rotate in the reverse direction. Now let us discuss about the clockwise direction first, and then you will get an idea about the anti-clockwise direction. Let me show you the picture here. So I have a north pole and I have a south pole, and I am connecting a positive polarity and negative polarity here. So I am giving a supply. Every time the motor is going to be connected like this only. Positive terminal here, negative terminal here. The switching is going to be same with the same polarities. Therefore the current enters into this conductor and current leaves from this conductor. If you stand here, the current is coming out of the conductor, so I can make it as dot mark. You can see, so the current is coming out of the conductor, it will be dot mark. And if you see here, the current is going into the conductor, so if you see from this point, now it can be marked as cross mark. If the current is coming out of the conductor, it's a dot mark. If the current is going into the conductor, it's a cross mark. Or simply coming towards the observer, dot mark, going away from the observer, cross mark. So I have north pole on the left side and I have south pole on the right side. And under the north pole I have a dot mark current carrying conductor. Under the south pole I have a cross mark current carrying conductor. So I have placed here the same. Every current carrying conductor will produce a flux that can be found by applying right hand thumb rule. Current is coming out, so thumb is going to indicate the current direction. Current is coming out on the left conductor, so the flux lines will be anti-clockwise. See, anti-clockwise. Current is going into the conductor, so the flux lines will be clockwise. See, the flux lines will be clockwise. Now if I place these conductors in the presence in between the permanent magnetic poles, then the permanent magnetic field and the current carrying conductor field will interact and creates like this. The resultant flux will establish like this. Why? Because the current carrying conductor flux lines are from current carrying conductors are anti-clockwise, and you see the permanent magnetic field quite opposite. This direction is here like this, this direction is like this. So they are going to oppose here, but at the bottom they are going to add. So this is going to be a strengthening field and this is going to be a weakening field. Similarly on this side, on the cross mark conductor, at the top the field is going to be strong or strengthening. At the bottom it is going to be weakening. And due to which because of difference in flux concentration, this huge flux lines pushes the conductor upward and this huge flux lines pushes the conductor downward, because the other side it's a weak flux line. Or simply you can get the force direction by applying Fleming's left hand rule. Forefinger will indicate the flux direction, middle finger will indicate the current direction, and thumb will indicate the force direction. If you apply Fleming's left hand rule on the dot mark, flux direction, flux is established from left to right, current is coming out of the conductor, so the force is upward. See, the force is upward. Now at the cross mark conductor, flux is from left to right and current is going into the conductor, therefore force is downward. So I am getting a force in the clockwise direction. If you fix the conductors with respect to an axis, then the conductors will rotate in the clockwise direction. This is how the motor rotates. Every time you switch on, it has to rotate in the clockwise direction only. Okay. Right. Now, I wanted to clear one point here. Every time I am going to switch on with positive and negative polarity, there is no question of changing in direction. There is no question of changing in current direction. There is no question of changing in current direction. Negative I, that means what? Instead of going in, coming out is not possible. Until unless you change the polarity, it is not at all possible. So this is not at all possible. Then what is the only possibility? If this is not possible, the only possibility is this one. The direction of flux lines establishment might reverse. That is, instead of establishing from left to right, if the flux can establish from right to left, then the force establishment will be in the anti-clockwise direction. Let's see how is it possible. So I have a north pole. I am trying to take. So if this is possible only in one motor, we have 4 different types of motors: separately excited, shunt excited, and what I can say, series excited and compound excited. Out of these 4 machines, only compound machine or compound motor has a chance. Why? Because there are 2 field windings. One is shunt field winding and another one is series field winding. And here positive is for cumulative compound and negative is for differential compound. If I assume this has shunt field flux and the series field flux is also going to be in the same direction, then the resultant flux is going to be very huge. It is not, the magnitude of resultant flux is going to increase and it is still going to establish from left to right. You see the resultant flux still from left to right. Now when it comes to differential compound machine, the series field flux lines are opposite to shunt field flux lines. The series field flux lines are opposite to shunt field flux lines. If the shunt field flux lines are greater than the series field flux lines, the resultant flux direction is still left to right only. That is north pole here, north pole on the left side, and south pole on the right side. Establishment will be. But for a change, if series field flux lines are greater than the shunt field flux lines, then the resultant flux lines will no more left to right. It will be right to left. See, if the series field flux lines are going to dominate the shunt field flux lines, then the resultant flux is no more from left to right. It will be from right to left. Now this will become south pole. On the right side it will be north pole. How is it going to happen is a question. Now here the series field flux line, if you are expecting the domination of series field flux line, it is going to happen only when the series field current is very huge. And the series field current is very huge only at the time of starting. Because at the time of starting, the motor will draw large current at the time of starting. So if such a large value of starting current, if such a large value of current enters into the motor at the time of starting, then the series field flux may dominate the shunt field flux, and it may result in establishment of flux lines in the reverse direction, and therefore the force will get reverse. Let's see the differential compound motor. If I look at differential compound motor, here is my differential compound motor. Generally the connection will be cumulative compound, differential compound. You can see the current direction you need to reverse. Okay. The moment when I close a switch, this voltage source is going to drive a current, and that current will tries to flow through the series field winding, and I can call this as ISE. And of course the same current will enter here at this junction and leaves as shunt field current and armature current. So the armature current is no more changed. Earlier also positive polarity, now also positive polarity. The same terminals are connected with the same polarity. Okay. The only change is series field flux direction. Series field flux magnitude is increased. Okay. If the series field flux dominates the shunt field flux, now there is a chance of establishment of flux lines from right to left. That means earlier this is a north pole, now it is going to become south pole. Under the north pole we have a dot mark current carrying conductor. Under the south pole we have a cross mark current carrying conductor, because of supply, the same polarity. Now what is happening now? Because of series field flux domination. Why? Because at the time of starting, current is very huge value. Therefore this series field current also, the same current is flowing through the series field winding now, and hence the series field flux is very high. Therefore the establishment of flux is from right to left. The establishment of flux is from right to left, like this. So this is north pole and this will become south pole. Now you apply Fleming's left hand rule. Flux is established from right to left. Current is going into the conductor, right? Now the force is going to be upward. Here flux is established from right to left. Current is coming out of the conductor. Now the force is downward. Now this is how an anti-clockwise direction of force is going to be established. Here is the reversal of flux polarities. And due to that we are getting an anti-clockwise force, and therefore the motor may rotate in reverse at the time of starting. Why only at starting? Because starting current is very huge, and it leads to series field flux higher than the shunt field flux, and the resultant flux establishment will get reverse. I hope it is clear for everyone. Thank you. Thank you so much. You see here, the rotation is reversed. Because I reverse the poles in the picture. So this will be north and this will be south. Earlier, right side will be south and left side will be north. Okay. Thank you. Thank you so much. Have a nice day.